Alright, here's the video for the final section of the semester, which is solving systems of linear and nonlinear equations. So here's the first system that we're going to solve today. Y equals 5 minus x squared, which we should recognize as being a quadratic equation, meaning a parabola, and y equals x minus 15, which would be a line. Now what I've done over here on the right side of the board is I've placed a graph of this system. Now please note that the x and y axes are both going up by 2. So if we were to graph that parabola and that line, the graph would look like this. Keep in mind that when we have a system of equations, whether those are lines or otherwise, we are always looking for the points of intersection between the multiple equations. In this case, there are two equations, a parabola and a line. The big difference between a system of linear equations and a system of nonlinear equations is that there can actually be multiple solutions. This is going to happen in most of our examples. So we need to keep in mind that there's not just one answer most of the time for these problems. Now these problems are going to combine a number of skills that we've developed over the course of the semester. So if we look back over here at this system and we're looking to solve this algebraically, then we're either going to be substituting or eliminating. Now, a lot of times with this kind of problem, elimination is not going to work well. There are two examples in this lesson that work well for elimination. So I will do both of those problems as elimination so that you can see how those problems work. This, however, is not one of those problems. If we look, both of these equations are solved for y. So this is a clear-cut substitution problem. We should take 5 minus x squared and substitute it into the second equation for y. This would result in the equation 5 minus x squared, because I've substituted this stuff in for y, equals x minus 15. Now we've been talking for the last several weeks about how to solve this kind of equation. This is a quadratic equation. We cannot solve a quadratic equation unless one side of the equation is equal to 0. And it's also very useful to us if the lead coefficient, which would be the coefficient on the x squared term, is a positive number. So we look to see whether or not x squared is a positive number. In this case, it's not. It's preceded by a negative 1. That means we really should move everything to the right side of the equation, because when we move x squared to the right side, its coefficient will become positive 1. Since we're moving everything to the right, we will also subtract 5 from each side, which would get subtracted from 15 because those would be like terms. This would leave us with the equation 0 equals x squared from here plus x here minus 20, because these would combine to negative 20. Now that looks a lot more like the quadratic equations that we've been working with. So what we need to do is check to see if that particular quadratic factors. Remember that when we factor a trinomial, like this one, we are always looking for numbers that multiply to c, so they need to multiply to negative 20, and adds to b, so they should add to positive 1, because there's a 1 right here. So if we go through every possible option for numbers that multiply to negative 20, there really are not that many options. One would have to be positive and one would have to be negative to multiply to equal a negative number. We're looking for the one that adds to positive 1. So it's not these two, because they're 19 and negative 19. It's not those two. It's one of these two. So we want the one that adds up to positive 1, which is here. So we want negative 4 and positive 5. This means that this trinomial will factor into two binomials, x minus 4 and x plus 5. Once we have it factored, we apply the zero product property from section 4-3. That says that since these two parentheses are being multiplied to equal 0, that one of those sets of parentheses must equal 0. So either x minus 4 is equal to 0, or x plus 5 is equal to 0. We would then go in and solve each of those one-step equations to get our x values for our two answers. So we would add 4 to each side of the first equation and subtract 5 from each side of the second equation. That gives us x answers. The x values are 4 or negative 5. These are the x coordinates of our two answers for this problem. Now, from there, what we need to do is figure out the y value that is associated with each of these x values. So we start off with x equals 4. The way we find the y value is we say to ourselves, if x is equal to 4, then I can take that 4 and I can plug it into either one of these equations. Now, I would use the bottom one because then you don't have to deal with the exponent. It should be simpler. So we're going to put that 4 in right here for x, which would be 4 minus 15, or negative 11. That means our first answer is the point 4, negative 11. Then we do the exact same thing for the other values. So if x is equal to negative 5, then y is negative 5 minus 15, or negative 20. So that would be the point negative 5, negative 20, x comma y. So those 2 points in the graph are the points 4, negative 11, and negative 5, negative 20. Okay, here's another one. This is also a substitution problem. The directions actually say substitution this time, but it's pretty much the same thing we just did. We're going to take the right side of one of these equations and plug it in for y in the other equation. So we're going to take that trinomial x squared minus x minus 6, and we're going to replace the y in the second equation. So that will give us x squared minus x minus 6 equals 2x minus 2. Now, we need everything on one side of that equation, and we need the x squared term to be positive. It is already positive, so we're going to move the 2x by subtracting 2x and the negative 2 by adding 2. That will move everything to the left side of the equation and set us up with a trinomial equal to 0, which will be something that we are able to solve. So that would be x squared minus 3x minus 4 equals 0. Now again, we're going to factor that. So we're looking for numbers that multiply to negative 4 and add to negative 3. Now when we're talking about pairs of numbers that add to negative 4, there are only 3 options there. So we just need to ask ourselves, which one of those adds up to negative 3? That would be 1 and negative 4. So we have x plus 1 and x minus 4 equals 0. Apply the 0 product property, x plus 1 equals 0, or x minus 4 equals 0. Then we're going to solve for x. So we're going to subtract 1 from each side in this equation and add 4 to each side in the second equation, which would give us our x answers of x equals negative 1 or x equals positive 4. Then we need to figure out what y equals. So we're going to take those two x values and plug them back into one of these equations. Again, the second equation would be the better choice. So if x is equal to negative 1, then y is equal to 2 times negative 1 minus 2. That would be negative 2 minus 2, or negative 4. So our first answer is the point negative 1, negative 4. On the other hand, if the x is equal to 4, like the second equation, or the second answer, then y is equal to 2 times 4 minus 2, which would be 8 minus 2, or 6. So our second answer would be the point 4, 6. Alright, let's look at a harder problem. Now this problem does not involve a parabola and a line like the last several have. This problem involves a circle, a radius root 10, and a line. So there could still be 0, 1, 2 solutions. There could be several possibilities here. So we just need to be very careful as we go through this problem. Now, what we're going to do is substitution again. We have y equals a binomial. So we're going to take that binomial, and my pen screwed up all the way through that, so let's try to clean that up. We're going to take that binomial, and we're going to substitute it in for y in the previous line. Okay, we're going to put it in for that y. Now notice I did not highlight the squared, because it only takes the place of the y, not the squared. So we would have x squared plus the quantity negative 3x plus 10 squared equals 10. So we are going to multiply that out. Now we have to remember that when we square something, that means it is being multiplied times itself. So what that really says is negative 3x plus 10 times negative 3x plus 10. So we're only going to be working on the blue portion of this equation for the moment, because we need to simplify this before we can do anything with x squared or 10. So we're just going to bring that x squared down. We're not going to do anything with that. Now the portion of this equation that's in blue comes from the 4-0 notes. This is multiplying polynomials. We had several different ways that we talked about how to do this sort of problem. We could do foiling, we could double distribute, or we could do the box method. I am going to use FOIL method. It's going to look a lot like double distribution because they're really the same thing. What has to happen is every term in this parenthesis, which there's two terms, has to multiply each term in the second set of parentheses. So we have to do negative 3x times negative 3x, which would be positive 9x squared. Negative 3x times 10, which would be negative 30x. 10 times negative 3x, which would be negative 30x, and 10 times 10, which would be 100. And that still equals 10. So just bringing that down. Now this is just a polynomial equation, and we can simplify it by adding some like terms. So we have an x squared and a 9x squared, which would be 10x squared. And we have a negative 30x and a negative 30x, which would be negative 60x. So we combine like terms on the left side, which would give us the equation 10x squared minus 60x plus 100 equals 10. Now this is a quadratic equation, so we need it to equal 0 before we can really do much solving. That means we need to subtract 10 from each side of the equation. When we do that, we are now looking at 10x squared minus 60x plus 90 equals 0. Now we can make this quadratic go significantly better if we realize that everything there has a common factor of 10, including 0. And we can divide both sides of the equation, which would be every single term, by 10. This will change the graph, but it will not change the roots of the quadratic. So it's perfectly fine that it changes the graph because we're not graphing. It's still going to have the same roots, the same zeros, the same solutions, the same x-intercepts. So that would change the trinomial into x squared minus 6x plus 9 equals 0. That trinomial will factor. We are looking for a pair of numbers that multiplies to positive 9 and adds to negative 6. There are only so many options. So the set that would add to negative 6, as I get ready to screw up, and oh good, I opened up a, that's wonderful. Get rid of that real quick. There we go. We go through here and we add these up, 10, negative 10, 6, negative 6. So we want negative 3 and negative 3. So this trinomial factors into two x minus 3 terms being multiplied together. When we apply the zero factor theorem, each of those would get set equal to 0 to give us one of our roots. which means this particular equation, this particular system, is only going to have one solution, because in both cases, for both factors, the solution would be x equals 3. So we don't need to test that value twice when we go up here and plug it back in. We only need to do that once. So if x is equal to 3, then we need to plug that in up here into one of these equations. Now again, you could do either one, but it's far easier to use the bottom equation. So we're going to plug it in down here. It would be negative 3 times x, which is 3, plus 10. That would be negative 9 plus 10, or 1. So the solution to our system, the only solution to our system, is 3 positive 1. Okay, let's take a look at an example that can actually be done with elimination. Now, how do we know that this can be done with elimination, you ask? Well, it's really all about the y's. If you notice, there's a y on the left side of each of these equations. The one in the first equation is positive, the one in the second equation is negative. That's how we know that this is an elimination problem. Because if I add these equations together right now, those y's will cancel because there's one positive y and one negative y on the left side. So what I'm going to do is something that you guys used to do all the time in grade school. I'm going to line up my columns. I'm going to make sure that my like terms for each equation are actually directly below each other. Now you'll notice I'm writing this negative 3 way out to the side because it doesn't technically combine with x squared or 3x. So that when I add these equations together, the only thing lined up are like terms, which would be the y and the negative y, and those will cancel. So then I add everything else down. I'd have x equals x squared plus 3x minus 3. Now from here, this is exactly like the other problems that we've already done. We're going to start by solving to get one side of our equation to equal 0. So we're going to subtract x from each side of the equation. That will give us 0 equals x squared plus 2x minus 3. Then I'm going to look for those numbers that multiply to negative 3 and add to positive 2. That would be 3 and negative 1. Shouldn't need to write out the list every time by this point. That'd be x plus 3 and x minus 1. We're going to split those up. So x plus 3 could be 0, or x minus 1 could be 0. Then we're going to solve each of those. So we have a subtract 3 from each side in the first equation, and an add 1 to each side in the second equation. That gives us x equals negative 3 for the first possible solution, and I really shouldn't circle it because it's not the answer to the problem, just the step. And x equals positive 1. Now we're going to take those, we're going to plug them in up above. Now this time I would actually plug them into the top equation because that equation is already solved for y. Makes it a little bit easier to evaluate. So if x is equal to negative 3, which is our first answer down here, then y is equal to x squared, which would be negative 3 squared, plus 3 times x, 3 times negative 3, and that's what we have to evaluate. So that would be 9 minus 9, or 0. So our first answer to our system is the point negative 3, 0. We're going to repeat that step for the other x value. If x equals 1, then y would be 1 squared plus 3 times 1. That would be 1 plus 3, or 4. So my second solution is the point 1, 4. 2 examples to go. Here's another example that is an elimination example. Now, look at that. You could think that that's a substitution problem. And again, that comes back to systems in general. Most systems of equations can actually be solved in multiple ways. It would be perfectly fine to do this example by substituting the trinomial in for y. But if you do that, you need to be very, very careful, because the negative in front of the y would then need to be distributed to all 3 terms. So, in my opinion, elimination, you are less likely to get yourself in trouble. Because again, all you're going to be doing is adding these two equations together because you have a positive y and a negative y on the left side of each equation. So again, we would go in here and we would write out the first equation, and then when we write the second equation, we would line up like terms. So when we go to eliminate, we add down, the y's cancel, and the 4's cancel, which actually makes this a much easier factoring problem. We are left with 2x equals x squared minus 3x. Again, we need that x squared term to be positive. It already is. So that means we need to move this 2x to the right. So we're going to subtract 2x from each side. That would give us 0 equals x squared minus 5x. Now that's not a trinomial, but that does still factor. Both terms in this binomial have at least an x. So what I do is I factor out the greatest common factor, which would be x, and would leave me with x minus 5. Then I apply the zero factor theorem, which says either x is 0 or x minus 5 is 0. This one is already solved. I don't have to do anything else with that one. But x minus 5, I just need to add 5 to each side like I've done before. And I'm left with the second x value of x equals 5. So what we're going to do with that is we are then going to turn our attention to figuring out what y equals. So we're going to take our first x value, x equals 0, and we're going to plug it into the first equation because that's the one that's already solved for y. So we'd say then y equals 0 squared, because it says x squared over here, minus 3 times 0, it's minus 3x, minus 4. And we simply evaluate what that is. So that would be 0 minus 4, or negative 4. So that would be the point 0, negative 4 for my first solution. I'm going to repeat those steps for x equals 5, which is my second x value. So I'm going to say if x equals 5, then y is equal to x squared, or 5 squared, minus 3 times 5x, minus 4. And I'm going to evaluate that, which would be 25 minus 15, which would be 10, minus 4 is 6. So my answer would be the point x equals 5, y equals 6, or 5, 6. Last example. Again, this problem could be done either with substitution or elimination. If you subtracted these two equations, y would drop out. But I'm going to do a substitution again, only because we haven't done one in a while, and I want to see, you should actually pause this video and try to do this one on your own to see where you're at. Alright, so what we're going to do is we're going to take this trinomial and we're going to plug it into the other equation for y. So we're going to take that trinomial, we're going to plug it in for y. So that'd be 2x squared minus 2x plus 3 equals x squared plus 5x minus 7. And we are going to solve that equation. So again, we want x squared to be positive. Now we have an x squared term on both sides, but if we subtract 2x squared, then that would be negative on this side. So that means we're supposed to move everything to the left. We're going to subtract x squared from each side. We're going to subtract 5x from each side. And we're going to add 7 to each side. That will result in a trinomial equal to 0, because the right side of our equation will now be 0, of x squared minus 7x plus 10. So we are looking for two numbers that multiply to 10 and add to negative 7. That would be negative 2 times negative 5. So this would factor into x minus 2 and x minus 5 equals 0. Break it up. X minus 2 is 0, or x minus 5 equals 0. And solve each of those equations. So we're going to add 2 to each side and add 5 to each side. That will give us x values of 2 and 5. We're going to plug those values back in, just like we did in the other problems, to find y. And I'm going to use the second equation to do that. So if x is equal to 2, then y is equal to 2 squared plus 5 times 2 minus 7, which would be 4 plus 10 minus 7, or 7. The pen is messing up here. There we go. Nice of you to rejoin us there. Let's get that cleaned up here. 7. So my answer would be the point 2, 7. Now the other answer might have freaked you out a little bit because it's kind of a big answer. If we take x equal to 5 and we plug it into that same equation, then y is equal to 5 squared plus 5 times 5 minus 7. That would be 25 plus 25 minus 7. That would be 43. So our answer should be the point 543. So I hope this has been helpful in systems of nonlinear equations. That does it for that section.